Autonomous Mining Track Remote Stop Transmitter Senior Design Video. We are Project Code 19059. We have been working with Caterpillar Inc., Jason Pagnotta, Engineer Manager, and mentored by Robert Messenger. The team members consist of a systems engineer, team leader, Rosie Diaz, mechanical engineer, Lourdes Mota, two electrical engineers, Jasper and Andrew, and two industrial engineers, Sarah and Clement. This is a representation of the poster. It concludes with a project description, materials, results, conclusions, supporting material references, which are going to be described throughout the video. Objectives of the video are the reviewing, verification, test, analysis, and results of the project. Introduction. The Autonomous Mining Track Remote Stop Transmitter is a redesigned and modified A-stop device from Caterpillar Inc. that is capable of sending signals that can stop the autonomous trucks in the vicinity. Our team has been focusing on obtaining a model that is reduced in size and that can be located in case of being misplaced. This is an illustration of the A-stop transmitter that contains 7 LEDs, 4 buttons, a charging port, battery charge indicators, and alarm silence. The system block diagram, it shows the interaction of each of the components in the A-stop device. It's the charger being connected with the charging port, the power supply, emergency shut off, microcontroller, going to the RF communications, and then the autonomous track receiver connected with the RF communications. In this use case diagram, it shows the interaction between the Caterpillar employee with the A-stop device sending RF communications to the receiver. It also shows the Caterpillar employee having access to the GPS system. The way it works is that the Caterpillar employee will download the phone application in any electronic device. Once it is being downloaded, the Caterpillar employee will have the username and password, and once it is logged in, the employee can have access to where it is to locate the device, and it doesn't need any Wi-Fi to use the phone application once it's being downloaded. The major requirements of the project is that must meet all RF specifications of current device, provide same user functions as current device, must be reduced in size, provide locating capability if lost or missing, and hold up a charge of 24 hours. Here is an illustration of the power analysis that we concluded for each components. We searched for the volts, currents, and power for each of them. In this thermal analysis, it shows the operating range that we had in mind for each of the components so it wouldn't overheat.
Now we will cover the design concept of the project. The first thing with the design is the battery. Since the battery consumed a lot of space in the original device, it was ideal to replace it with a flat battery in order to meet the size reduction requirement for the project. So we picked this polymer lithium-ion cell. It has large capacity of 5,000 milliamps per hour. It has compact size. It is safe to use. Second, for the packaging material, we picked polycarbonate because it has a good water and shock resistance, but it is expensive compared to other materials. For the GPS, we picked Land Air C54 GPS because it is small in size, it has a limited data storage, and most importantly, it is a cellular GPS. And that's perfect for the project since it doesn't require a Wi-Fi connection. Here is the GPS phone application setup for the Land Air C54 GPS and how to activate it for the first time. First, the battery testing. Since we replaced the 1.2 volts battery with a 3.7 volts flat battery, we had to introduce a resistor for the battery so that it doesn't overpower the device components and burn them. So from measuring the current that the device needs, we were able to find the right resistance value, which is about 27 ohms. We also did a GPS accuracy test since our project requires a GPS accuracy of 5 meters or less. We did the test through measuring the distance between the GPS location shown in the phone application and the GPS actual location. From the results, we can see that our GPS has the required accuracy for the project. Here are some pictures of the GPS phone application taken while doing the accuracy test. Here is a picture of our first prototype. This prototype statistics failed and need to further reduce the size of the device and possibly change the middle part component with more elastic material.
In this slide shows the A-step case, the before and the after. The green is the last result that we concluded with. This is a SolidWorks illustration of how the A-step transmitter will be looking like. Here are SolidWorks illustrations of the A-step packaging with the measurements in inches. This is a 3D print polycarbonate case result. The 3 layers of our system will be sealed by a IP68 sealing. As a result, all the components that we have chosen have passed the system requirements. In order to reduce the size of the A-step device and to locate in case of being misplaced, we will be using the GPS, the polymer ion cell, and the polycarbonate material. In conclusion, all the requirements were met. Due to COVID-19, we were unable to finish the final prototype to package everything together as the GPS and the new battery to work on physical tests. But we have made advances for the redesign A-step. The parts that were changed or added from the original device are the GPS chip, the case of the original remote, and the battery. The transmitter has passed the necessary requirements to function and operate to specifications.
In all, this is our budget summary, which is still within our $4,000 budget. The grand total of our budget, including customer supply parts, is $5,951.29. Here are the customer equipment deliverables. We have to return the two-way stop transmitter, receiver, and antenna, and presumably the redesigned A-stop device, but because of the coronavirus, we are going to deliver our prototype instead. And all of them are due on 40th May. Over the course of this project, we have learned a lot of lessons from the challenges we faced. One of the biggest challenges is working with limited resources and information. We overcome this by making the best decisions for the team and work with what we have. Through this, we gain skills in communication, leadership, engineering, and more knowledge in the industry.
Safety and environment. The changes made in the redesign does not affect the original safety code or the environmental code, as it follows the same safety code provided by Caterpillar Inc. Objectives have been completed and being demonstrated throughout the video.